Hello, everybody. Welcome to Lecture 6, where we will be moving into our chapter on attention, which is personally my second favorite topic in cognitive science. Memory is first, attention is second. And as I learn more and more about attention, I begin to believe that it may actually be kind of the same thing as memory. But I'll let you all decide for yourself as we get through this. So before we get started, you will have your first article comprehension check this week. There'll be a separate video for that, so I'll walk through the article, what I expect from it, how to do the assignment. So you'll have that as well. I think that's about it. You do have your first exam coming up in a few weeks. So I will probably likely be holding at least 1, 2 live sessions, question and answer, so people come by. If they have any questions, we can talk through it. If people are interested and can make it. So I'll send out a poll, I think, at some point and see if people are first interested in doing it and have the time. It'll probably be during my office hours. So keep an eye out for that. All right, so let's get into today's lecture where we'll be discussing attention. We'll first talk about what is attention, which seems like a simple question, but in reality, it's not. And then we'll talk about some theories of attention. People trying to make sense of this really complex topic. So what do you think attention is? Take a moment and think about it. What comes to mind? What do you think of when you think of attention? I had an interesting thing happen to me not too long ago. I was driving to a friend's house. He just got out of the military. He was at his parents' house. I was going to visit. And I hadn't been there in it was probably like 10 years. And as I was driving there, I was just driving, focused on the road and my thoughts and whatnot. And all of a sudden, I just noticed a house on the left, and that the house had been painted a different color. That it was gray and now it was blue. And I went, I got to my friend's house and I asked them, and they said, "Oh yeah, they used to be gray and they painted it blue, whatever, some time ago." And it just occurred to me as how just odd that was, that my brain somehow picked up on that. I wasn't paying any attention to it. I wasn't focused on it. I wasn't thinking about it, but somehow my brain just noticed this house that I hadn't seen in 10 years and that it was a different color. And it has always just stuck with me as how incredible that is. And something like that shouldn't really be happening when you think about it. When we think back to our like information processing system and how that sensory information, comes in. So all the stimuli in my environment is all coming into my brain, but I'm not processing all of it, right? I'm just sort of taking the important stuff and processing it. It's somehow this random house that I was not focused on or paying attention to. It was not at all significant. Somehow my brain noticed this. So that's just something that I've always found very, very interesting. So attention, what is it? Well, this is not going to be like other topics where, pattern recognition, information processing, or memory, where we have these real concrete definitions. Attention is not going to be like that. You'll see that we have competing definitions in attention. And one of the early researchers in this field, James, stated that everyone knows what attention is. And we think we know what attention is because we use it all the time. We're always talking about paying attention, pay attention. And we think we know what it means, but do we? I mean, do we really know what attention is? Also, some people think of it in terms of, or I think we often think of it in terms of almost like a currency, where we have this amount of attention that we can spend. So if you think of them like coins, where we can spend our attention coins on various things. And the more coins we spend on something, the more we should be able to attend to it. And thinking about, my driving in that house, I wasn't spending any coins. I was spending no attention coins on that house, yet somehow that still got into my brain and became, so I somehow processed it and derived meaning from it. So maybe it's like that. Maybe it's like coins and we can spend attention coins on things, perhaps. There are a couple aspects of attention that we can give concrete definitions for. So overall attention, we'll see that we have some competing definitions, different theories, and people have different thoughts on it. But there are a couple core tenets within attention that we can have concrete definitions for. One is selective attention. So this is our ability to focus on one thing and attempt to ignore everything else. So I know that that's usually not possible. It's hard to do this. It takes a lot of effort. You can all think about when you're trying to focus on one thing and block out other stuff. It's really hard. I mean, it actually takes a lot of effort, right? It's tiring. It wears you out. But that is selective attention. Whereas divided attention is our ability to process, multiple things at once. And a lot of people will think of multitasking here. And this is similar to when we talked about studying and cramming and how people often think that cramming works well, but in reality it doesn't. It's the same here. We all multitask because we have to, but you will never do any one thing as well while multitasking as you would if you were just using selective attention, focusing on just that one thing. So our two sort of facets of attention here are selective attention and divided attention. So we'll go through a quick history of selective attention and kind of how this has been thought of throughout history. Because people have thought about this, going all the way back to Aristotle, how Aristotle talked about it almost as like a beam of light, where it's just one single focus and that you cannot split your attention between objects in space. So he would not have been a proponent for divided attention. He would have been a proponent for selective attention, that we can just do one thing. That's our attention is like a laser beam. And we just focus it on one thing. Whereas Augustine talked about, was, I think, well, at least on record, the first to talk about how our attention can be involuntarily captured, which I'm sure has happened to all of us. Happens to me all the time. I'll be out for a walk, and one of the apparently favorite things of people on Long Island to do is to make their cars as loud as possible. So they buy those exhausts they put on their car that does nothing for performance, but just makes it really loud. And every time I'm out for a walk, one of those will go zooming by, and my attention is involuntarily captured by it. I won't say what I want to do. I won't talk about the action I wish to perform after that happens, but my attention is involuntarily captured. I'll be listening to a book on tape or whatever, music, thinking about, the next lecture I'm going to give. If that's where my attention coins are being given, then all of a sudden, boom, something happens, and there goes my attention. So getting to modern times, William James, this is the first psychologist, the first scientist to really tackle attention in a modern sense and try and understand how it works. So as I've talked about many times, everything that we discuss in this course has been rigorously studied. So this isn't guesswork. This isn't, well, I think it's like this. No, this is all done through rigorous scientific work. So William James was the first one to really apply this to the concept of attention. And as James said, everyone thinks, at least thinks they know what attention is, and that it is taking possession by the mind of one possible object or train of thought out of many. So we all have many competing thoughts, for example. So we all have, this is getting a little bit out of cognitive science, but we all have what are called automatic negative thoughts, ANTs. So this is getting into clinical psychology, but we all have them. Those are those bad thoughts where, you're no good, you stink, you're terrible, blah, blah. and everyone has them. They're normal. And one of the methods by which people are treated to handle those is to learn to focus their attention. So you first identify that you're having this unwanted thought, and then you learn to train your attention to block it out and focus on your thoughts, because those are involuntary thoughts. You're not creating them yourself. They're just thoughts that we all have. So one of the ways that we try and deal with that is to train people to attend to the thoughts they want to have and block out those thoughts, the automatic negative thoughts. So James started work on attention. What is it? How does it work? And then, as we talked a little bit about before, behavioralism clashes with cognitive science. They don't mesh well. They're oil and water. Behavioralism became huge in the early 1900s, and then attention research and most of cognitive science was put on hold for about 40 years or so. Then something happened, which I'll give you a moment to think of, to try and think of what happened in the mid 1900s that would make people want to understand more about cognitive processes and what's actually happening under the hood. Why do people do what they do? Well, Second World War. World War happens. There are a lot of technical advancements, but also a great desire to understand human behavior. Why do people do what they do? Well, that led to cognitive science, and in this case, the study of attention, making a comeback. People desperately wanted to understand how the human brain works. We just went through this cataclysm, and we need to figure it out. Behavioralism is not giving us the answers. Behavioralism is falling short. So we go back to cognitive science. And one of the first, Cherry, in 1952, in the study of attention, pioneered the dichotic listening paradigm, in which he used something called the shadowing task. So what is the shadowing task? Okay, so essentially you have a participant and you give them a pair of headphones, and then you have two messages. So in this example here, we have what's called the primary message. This is the one that the participant is shadowing. So they're told, pay attention to the message coming in your right ear. Simultaneously, they're getting a message from the left ear. They're told to ignore that. So you shadow and pay attention to the primary message in your right ear, ignore the message in your left ear. So what would this be an example of? What are they testing here? They're testing selective attention. Now, one of the questions that this kind of research raised was how much of that secondary message is getting through. This is fundamental to studying attention, right? If we are selectively attending to the message in our right ear, while at the same time we're getting a message in our left ear, how much of that is getting through? It used to be thought that everything was getting through and you were processing it all and it was all happening. But people then started thinking, well, maybe not. Maybe that's not what's happening. Maybe only some of it's getting through. So to test this, Cherry tested this, and he tested it using that shadowing task. And what they found was that while they're doing this shadowing task, they would ask participants afterward to report what they heard in the unattended ear, so the ear they were ignoring. And what they found was that they could report certain physical feature characteristics of the stimuli. They could, how loud it was, the pitch, the location, things like that. But they could not report any meaning. So they didn't know what it was. They could just say, oh, it was really loud, or it beeped, or it sounded like it was going in different areas, but they didn't know the meaning of it. So no meaning was coming through. And then Murray in 1959 did a similar task. Here he just repeated a single word. So they had the same thing. They had headphones on, two different messages. And here he repeated a single word. This is in the unattended ear. Repeated the word house 35 times, over and over, 35 times. And then when later asked about it, they couldn't say what that word was. So they have headphones in the right ear, they're getting dolphin. And then the left ear, they're getting house. And they're told, pay attention to the right ear, pay attention to the right ear. Say that right. So, often they would say, repeat the word you're getting in your right ear over and over. And then afterwards, they're asked, well, what was the message in the left ear? And they couldn't say what it was. Again, all you could get from them was some kind of physical character. They could say, oh, it was really loud, it was really quiet, but they didn't extract any meaning from it. So what did they take from this? Well, they interpret this for evidence of what we would call a perceptual limitation, meaning that people are able to or unable to process a message going into their unintended ear when they're shadowing a message going into their intended ear. So this was a really critical finding and a really interesting one. And it began the search for understanding how attention is actually working. So it's not just this everything's coming in, everything's being processed. No, it's actually limiting that. We can only process a certain amount of information at a time. So this leads us to Broadbent, who developed the very first model of attention. So when we talk about models and theories, which are the foundation of science, this is the very first one, the very first model of attention. So we'll walk through all of it here. So Broadbent's first model of attention. So let's think of these two pipes here. So our two arrows, let's think of these as the right ear and the left ear. And let's think of these little balls as information. So this is the stimuli, the information, the sounds that are coming into your ears. So all the information that's coming into your ears. And in order for this information to be processed and to extract meaning from it, it has to make it to this channel here. This is the channel where meaning is being processed. So as it comes in here, what Broadbent said was that this is what would be called a sensory store. He called it sensory memory. It's a sensory store. And what's happening in this stage is there's a very holds a ton of information. So all the information is coming in, and what the brain is doing is extracting features from it, just physical characteristics. So is it loud? So color is it large? Just those physical characteristics. So if you think back to our last lecture, we talked about feature detection theory, how we're identifying features in objects and using those to build up an object representation. Broadbent's saying that at this stage, that's what we're doing, just extracting the features. And in order to actually assign meaning to it and understand what the object is, it must get into the central channel here. Once it does that, we identify it, we recognize it, we can act on it. This line here is called the filter. So this would be where Broadbent places attention. Broadbent says that there's a filter, and that this is what blocks information from coming in. So that we use this filter to limit the amount of information that is allowed to process. So this brings up a question of attention now being limited, right? So if everything has to go into a single channel, all the stimuli is coming in, it's all got to go into this single channel, then it has a limitation. There's essentially a bottleneck, if you. And this is what he was using to attempt to explain why during those dichotic listening tasks, the participant can't remember everything from both ears, why they can only remember stuff from one ear. It's because there's this bottleneck. So if the shadowing task is saying, listen to the information in your right ear, attention is being used to filter out, to block the stuff coming in the left ear. So remember, they still got the physical feature characteristics of it. So they can still say how loud it was, the pitch, so on and so forth. So that feature stuff is being processed. But the filter is blocking it out and not letting it through to be processed for meaning. So all of the sensory information is coming in parallel, meaning that it's all being processed at the same time. But once it is allowed through our central channel, it's being processed in a serial fashion, meaning one by one. And that's where this limitation is occurring. That's where attention is limiting how much you can process at any given time. So this is essentially Broadbent explaining why these attentional limits exist. So this bottleneck that's occurring in the central channel here, this is a central feature of Broadbent's model. This describes that point in the processing system where the flow of information is restricted. And the idea here is that our cognitive system has a limited capacity for processing information. And as a result, can only handle a limited amount of sensory input at any given time. And that the amount of information coming in from our perceptual channels exceeds the rate through which we can process it. So too much coming in, we can't process it all, and we therefore need attention to control this, essentially, to control the overwhelming amount of information coming in. So think about that for a moment, if you think that makes sense, if you agree with that. It was really quite brilliant. I mean, especially, being these early days of studying attention, it's really a very clever idea. So Broadbent would define attention as the process of prioritizing. So that's how Broadbent would define it. He would say that attention is prioritizing information, and that it acts, attention behaves like a filter. And this filter is what is blocking out the irrelevant sensory information and letting the important information be recognized. And that this attentional filter is that this is allowing important information to be selected and sent down the central channel, where it is processed for meaning. So again, think about that and try and think about some questions or some problems, maybe. What are some issues with this? Let's maybe think back to my example of driving, noticing that house. So what was happening? So I'm driving, all the stimuli is coming in, right? So every visual thing in my environment, a sound, every smell, it's all coming in. It's all getting into my sensory store. I'm processing the physical features of it, but I'm not extracting any meaning. Now, my attentional flap would have been locking out things like the houses on the side of the street. I'm not paying attention to those. They're not important, so I'm blocking those out. I'm processing the basic features, but I'm not extracting any meaning. Yet somehow that got through my central channel. Somehow the fact that this house, somehow my memory told me that this house used to be a different color, and I somehow noticed it. So that information somehow got, which is really curious, and it doesn't quite fit with this model. So what would be like the major problem with this model? Right. So again, just another example. If you're at a Yankees game, and this is the information you want to process, you want to listen, you want to watch the players, and maybe listen to the announcer. But you've all these people over here talking. Your attentional flap is trying to block these noises out, and you're trying to let this through. But think about one very important issue, which is, how does the attentional flap know what the important things are if they haven't been recognized yet? So this is one of the major questions with Broadbent's theory. if you're not processing this for me, so you're not recognizing, essentially what we're saying is that you're not recognizing any of this information. So what Broadbent would say is that even though the visual stimuli of that house made it into my sensory store, I didn't recognize it. I just did some basic processing on the features, but I didn't recognize the house. But yet somehow I still noticed it and did extract meaning. So how do we know what is important? So if all the sensory information is coming in and all we're doing is just processing the physical characteristics of it and not the meaning and not recognizing it, then how do we know what is important? How do we know that? Well, I can tell you what Broadbent used, what his answer was. Broadbent's answer was that it is possible to analyze an object into its basic features without recognizing it, and that this is what our feature detectors do. So, okay, so I'll agree with that. I think that is possible. It is possible to analyze an object by just basic features first. Like, I think we can do that because we do have these, we talked about feature detectors in the brain. So we talked about that, and that we have simple cells and complex cells, and that these recognize different orientations. So, okay, we can do that. But Broadbent went on to say that our attentional filtering, so deciding what to focus on and what not to focus on, this is actually done using these low-level basic features. So that we're deciding what to pay attention to, not based off of what we know it is, but just based off of basic features. So essentially our brain, our sensory system, is doing this without our conscious awareness. So our sensory system is using features of objects and then selecting them for us to pay attention to, and then we process it from it. So think about that, and maybe, think about if that's something, think about if you buy it. I'm curious to know if people buy that. Do you think that's accurate? I'm not sure I do. I'm not sure I do. But we'll talk more about this a little bit later on. But this is one of, if not the major concerns with Broadbent's theory. So how did Broadbent test all of it? So obviously, all this is done through rigorous scientific work. So how did he actually test his hypotheses? Well, he used Cherry's psychotic listening paradigm. What Broadbent did was he had a participant put on the headphones, and they had 6 digits. And they would present these 6 digits as pairs. And then the digits from each pair were presented simultaneously to different ears. In between each pair, there was a 500 millisecond delay. And then after all the pairs were presented, the subjects were given a recall. Okay. So that's how he designed his experiment test. So he's testing the flap. Okay, he's testing that attentional filter. He's testing to see if the filter is actually there and if it's actually working. So for example, if we had 734-215, you'd have 741 go in the right ear and 325 go in the left ear. So what did they find? Well, he found that 65% of subjects who recalled them correctly reported them back as either 741-325 or 325-74. Okay, so what does that mean? It means that they reported the digits heard in one ear, followed by the digits reported in the other. Right? So they get the digits in the right ear, then they report those, left ear report those. So Broadbent took this, interpreted this as being evidence for his model. He suggested that this actually does support his model of the attentional flap. So if the left channel is the left ear, left auditory channel, the right channel is the right auditory channel. Broadbent suggested that this flap, this attentional flap, is actually what is determining what information is entering. And what's happening is that this attentional flap is essentially swinging from one ear to the other one, and that it takes some time for this to happen. So you're selectively attending this year, then it swings over, and it's selectively attending this year, and then back and forth. And that by processing all the digits going in one year, and then followed by the digits going the other year, you're limiting the number of attentional units. So you're using your attention in a methodical and productive way. So he thought this to be evidence for his theory that they saw this sequential process. So Broadbent, in addition to this early model that I mentioned, Broadbent also was responsible for what we would call the first box model of information processing. So you've all seen this before. Our box model of information processing. So yeah, it's very similar to what you've seen before. So we'll walk through this as our original information processing system that we've seen in previous lectures. We're going to work left from right. So as with the systems we've seen before, it all starts with all the sensory information coming in to our sensory store. Broadbent called it sensory memory. I don't like that term. I don't like the term memory being applied here because I don't think it is memory, but that's fine. We'll call it what Broadbent called it, which is sensory memory. So everything comes in and it's briefly held in your sensory memory. Attention, or the flap, so Broadbent's attentional flap, this is applied to select which sensory information will proceed on to the next stage. And Broadbent, importantly, he's suggesting that this filter is occurring very early and is preventing all the non-selected, non-important information from being processed for meaning, right? So we're only processing for basic features here, not for meaning. Attention is applied, the flap is applied, information goes down the central channel, and that is where it is processed for meaning. So only once the filtered information reaches this recognition stage is where it is processed and recognized. So this involves deeper processing and interpreting of the selected information. Attention then determines what information is sent on short-term memory, where you hold it briefly in your conscious mind, if you will, think about it, interpret it, and then we can act upon it. So the culmination of the whole process is our output and behavior, right? So stimuli comes in, we process all of it for basic features. The attentional flap determines what proceeds, and it is doing so based off, according to Broadbent, based off of physical characteristics, not meaning. It's sent on so that it can be processed for meaning. Once it is processed for meaning, we then have it available to us. So it's now available in our short-term memory. We think about it and we can act upon that information. So think about this if you think that makes sense. Are there any shortcomings here that you can think of? What do you think about it? Do you buy it? So this here, we just have it applying this to Broadbent's model, right? So info from the world, sensory memory, are these two upper tubes. Each little ball represents the stimuli coming in. And at this point, we're just all we're doing is processing the basic features. Our flap, our attentional flap, decides what gets let through. That is what Broadbent calls attention. Once it is let through, we then process it for meaning, recognize it, and then we act on it. So really pretty clever. I mean, really quite brilliant. When you think about coming up with all this, really is. So one of the major questions that stems from Broadbent's filter model and was somewhat of a critique of it is what we would call early selection theories or theory. So at what stage is the information being processed and what areas are being processed from. So Broadbent, with his early selection theory, he would say that information comes in and all that raw data is being processed in parallel, so all together. So the features of everything is being processed at once. The information that is selected based off those features is sent on. At this point, it is now serial processing, so one bit at a time, and that this is where that bottleneck is coming up. Single channel. And that because of our limited capacity for processing information, not all sensory input can be processed for meaning simultaneously. So Broadbent, the key point in Broadbent's theory is that not all sensory input is processed for meaning. Only that which is sent on is processed for meaning. So this leads to a big debate, or I should say, did lead to a big debate. This is all work from the 50s and 60s. But it led to this big debate as to how processed is the unattended information. So the information that Broadbent says that we're filtering out. There's a question as to whether or not we are processing that for meaning. So our early selection theory, which Broadbent and Treisman are proponents of, suggests that our attention acts as a filter early in the processing stream, and that this filter is occurring before any meaningful processing of the sensory input occurs. As a result of which, only the selected information based on those physical characteristics, such as location, pitch, color, is then processed for meaning. So the unattended information, the filtered out information, is only analyzed for basic perceptual features, not semantic content or meaning, which means, of course, that the unattended stimuli are filtered out before they are recognized as objects or giving any meaning. Contrary to this is late selection theory, where late selection theory argues that all sensory input is processed for meaning prior to the filter being applied. So according to them, according to late selection theory, our cognitive systems process all incoming information to the level of recognition and semantic analysis, regardless of whether it is attended to or not. The filter is then applied after semantic processing, which means that even the unattended information is processed to the point of understanding and recognition. And that only at this later stage is the decision made about which information to bring into conscious awareness or to act upon. So that's an important point. They're saying that all the information that's coming into our sensory store is processed for meaning, but that only the information we let through, we become consciously aware of. Okay, that's an important point. And it suggests that unattended information, so the information that's unattended, can influence behavior or decision-making because it is processed to the level of recognized objects and meaning before being filtered out. So, what do you think? Which one do you think is correct? Do you think either is correct? Do you think they make sense? Which one makes more sense? Does the brain work like this? We could think about my example earlier of driving and then noticing that house. Which one would that fit? I think that would fit late selection, right? Because what we're saying is that the information from that house and the fact that the colors changed, that it came in and I processed it for meaning, and then for whatever reason, my attention led it through and I was then consciously aware of it. Right? Whereas early selection theory would state that I just process it for physical characteristics, not for any meaning, but then for some reason it was still let through, where I then processed it for meaning and became consciously aware. So I think they both have good points, but this is the debate in that stems from Broadbent's work. is what level of processing is occurring to that sensory information. So I think this is where, yeah, we're at just about an hour. So I think well actually I think we'll end it here. So we'll end at the beginning of this debate. So as Winston Churchill once famously said, this is not the end. This is not even the beginning of the end, but this is perhaps the end of the beginning. So we'll end here for today, at the beginning of this debate. So when we pick up for Wednesday's lecture, we'll discuss the early versus late selection debate. We'll see who won, who lost, and we'll then talk about a couple more theories of attention and have some fun with that. So I think, yeah, that's about it for today's lecture. Remember to watch, there'll be another one, a short video where I walk through the article comprehension check, how to do that, what I expect from it. So make sure to watch that. And as always, any questions, issues, concerns, let me know. And I'll see you all in the next one. Thanks.